the remarkable mind-reading robot servant that humans can control using nothing but their thoughts and hand gestures. A robot servant that can be controlled using the power of thought has been developed by MIT engineers. The machine, named Baxter, reads human brainwaves in real time so that it knows when a human is unhappy with its actions. If a human thinks a mistake has been made, Baxter takes notice and corrects himself. Baxter's owner can then make subtle hand gestures to direct the machine into performing a different task. Scientists say the technology is designed to make robots act like an extension of a person's will, without any training. The team at the Massachusetts Institute of Technology, MIT, say the system improves Baxter's decision-making from 70% to 97%. The project's supervisor Daniela Russa said that the goal is to move away from a world where people have to adapt to the constraints of machines, to develop robotic systems that are a more natural and intuitive extension of us. A team, led by Massachusetts Institute of Technology Computer Science and Artificial Intelligence Laboratory, MIT XAIL, demonstrated the system on a robot using a drill. In the test, the robot moves the power tool to one of 3 possible targets on a mock plane. Importantly, they showed that the system works on people it's never seen before, meaning that companies could deploy it in real-world settings without needing to train it on users. To create the system, the team harnessed the power of electroencephalography, EEG, for brain activity and electromyography, EMG, for muscle activity, putting a series of electrodes on the user's scalp and forearm. By looking at both muscle and brain signals, we can start to pick up on a person's natural gestures along with their snap decisions about whether something is going wrong, says PhD candidate Joseph Del Prito, who was lead author on the paper. This helps make communicating with a robot more like communicating with another person. Both metrics have some shortcomings. EEG signals are not always reliably detectable, while EMG signals can sometimes be difficult to map. By merging the two, the team found a way for more robust biosensing, which makes it possible for the system to work on new users without training. This work combining EEG and EMG feedback enables natural human-robot interactions for a broader set of applications than we've been able to do before using only EEG feedback, says XAIL director Daniela Russ, who supervised the work. By including muscle feedback, we can use gestures to command the robot spatially, with much more nuance and specificity. The team says that they could imagine the system one day being useful for the elderly, or workers with language disorders or limited mobility. The research will be presented at the Robotics, Science and Systems, RSS, conference taking place in Pittsburgh next week.